In this video, we are starting section 3.1 on the definition of a function. So our goals are to define what functions are and test how we can tell something is a function or not by the vertical line test. Then we'll discuss how we can evaluate functions and plug certain values into them and simplify and figure out what they end up outputting. And finally, we'll go over how we can get the domain and the range of functions. All right, so in this video, I want to focus on what a function is and how we can test whether something is a function or not. So let's start with the definition, which says that a function associates every number in some set of numbers called the domain to exactly one number. Okay, so what does that mean? You might recall that with a function, we can plug numbers in, and then when we do that, we get one number out. And that's what this definition is saying. It's saying that, for every number that you can plug in, and the collection of numbers you can plug in, we call that the domain. All the things you can plug in, that is the domain. And when you do plug in some value into the function, we are going to get exactly one number as an output. So that's what this definition is saying. So let's look at an example. Let's say f of x equals x squared, and we have this function. So one way I can think of a function is as a machine, and I'm going to draw like two tubes in the machine. So there's one tube where I will plug something in, and I'll draw another tube over here where I get something out. Okay, and let's say that I am plugging in the number -4 into this machine. So -4 is going to get plugged in where the x is, and then that number is going to get squared. And when I square it, I get 16. So that is the output of the function. So for every single number like the -4 that I plug in, like 0, or I could plug in pi, or 102, any number that I plug in, I can square it, and whatever I get when I square it, that is the output of the function. Okay, so there's 4 common ways that I can express functions. One of the ways is by using an equation, and that's the way that we just saw. So the equation for this function is f of x equals x squared, or I can call that the formula for this function, either an equation or a formula. That's one way to express a function. So I talked about domain here being, all the things you can plug in. When the domain of a function is not given, this implies that it's the largest possible domain. Okay, so as an example, let's look at the graph of the function, and that happens to be another way we can express the function using graphs. So, I can write this formula also as y equals x squared. And currently in the formula, there's no domain that's specified. And because of that, it means plug in all the x values, all the inputs that we can. And, when we plug in any number in for the x, I'm never going to end up with something undefined. Like I'll never divide by 0. I'll never get a square root of a negative number or anything that makes it undefined, no matter what number I plug in. So that means, the domain is going to be the largest possible thing. So for this graph, the domain is going to be everything from -infinity to +infinity. So what does a graph of y equals x squared look like? We've seen that before in the last chapter. That's just our upward-facing parabola. Our upward-facing parabola, that's a graph of y equals x squared. And even from the graph, I can tell that this is the domain because, the graph keeps on going to the right forever. It keeps on going to the left forever. There's no x value. There's no input that gets skipped. Okay. All right. So what if I gave the exact same formula, but this time I specified a range of x values? That means I'm specifying the domain. Well, in this case, I'm only going to look at part of the parabola. The part of the parabola from where x is -3 to where x is 2. So drawing that, here's my vertex. When x is -3, because of the equal sign, I'll have a closed circle. And if I plug -3 in to the formula, the y value is 9. At 2, though, there's no equal sign, which means once the parabola reaches 2, I'll put an open circle there. And if I plug 2 in, the y value would have been 4. Okay. Alrighty, so for this graph, the domain is specified, and I have a bracket at -3, and a parentheses at 2 because that's not included. Okay, so that's the second way I can express a function, as a graph. The third way is using a table of values. So I can keep track of my input, which I'll call x, and the output I'll call f of x, or I could also call it y. And let's plug in a few inputs, like -2, -1, 0, 1, and 2. If I plug in -2, we get the output is 4. If I plug in -1 and I square it, I get 1 out. If I plug in 0, I get 0. 1 gives me 1, and 2 gives me 4. So those are my outputs when I plug these numbers in for the x in this formula. Okay, so one of maybe the disadvantages of having something expressed in this table form is, well, it would, especially if the domain is all real numbers, it would take me forever to plug in all the x values. So, I can only get so much information by plugging in specific x values. But, often I might, in the real world, I don't always have a formula for my function given. Often I have a bunch of data points that I got to work with, and those might be given to me in table format. Okay, the fourth and final way to express a function is using words, or sometimes I can call this as using a model. So this formula, f of x, one of the things I can say is, well, it happens to be the area of a square with side length x, right? Because the area of a square is that side length squared. Okay, so those are the 4 ways I can express a function. All right, so we talked about domain a little bit. Let's give a definition for range. The range of a function is all of the achieved outputs, all the values I actually get as an output. So domain was all of the inputs, or we can call those the x values. I'll abbreviate vals. Okay, and the range is all of the outputs, all the outputs we end up getting. And these are the y values. These are the y values. So going back to my graphs, these 2 graphs here, let's write down the range for each one. So the range for this first graph and the range for the next one. So range is y values. The smallest y value happens to be at the origin. That's the lowest y value I ever get, and that's 0. I do reach that point, which means I got to put a bracket there. I achieve it. And then as I go to the right or as I go to the left in the graph, the y values get bigger and bigger and bigger. So we would go onwards to infinity. Okay, in my next graph, the smallest possible y value, again, is at the vertex. So I would put a bracket at 0. And then the y values get bigger and bigger and bigger, and the highest y value I reach is 9. So I put a comma 9, and I do have a closed circle at 9, so it's achieved, and I put a bracket there. All right, so what I want to end the video with is by talking about what's called a vertical line test. It turns out that a function has to pass the vertical line test. And what that says is that any vertical line that you draw in the graph, it's got to cross the graph at most once. All right, so let's look at an example where I'm going to draw 2 things. One that is a function and one that isn't a function. So first, we were looking at this formula, f of x equals x squared. Let's just recopy the graph. And that was our upward facing parabola. And if I look at this graph and I draw some vertical lines, so this vertical line, that just crosses the graph once. So that's fine. If I draw another vertical line, that also crosses the graph once. So that's fine as well. It just cannot cross the graph more than one time, but at most once is totally fine. Let's draw one more. And this one also crosses the graph once, so we are fine. And it's not hard to see at this point that if I were to draw any other, vertical line, that's going to cross the graph one time, and that's totally fine. So that passes the vertical line test, which means this is a function. So now let's draw the graph of something that isn't a function. So for this, I want to have you first pause the video for about 30 seconds and see if you can draw a graph that wouldn't be a function, that's not going to pass that vertical line test. So pause it in 4, 3, 2, 1, pause it, and see if you can draw a graph of something that's not a function. All right, so hopefully you did that. Hopefully you tried that. Let's talk about it now. So there's many possible examples, but I'll draw one possibility, which is if I have a circle. So if I have a circle, and we talked about circles in chapter 3. So let me say my circle is centered at the origin, and let me give it radius 1. So then let's practice writing the formula. So the formula for the circle would be x minus 0 squared, because the x coordinate is 0, and well, it would be y minus 0 squared, because the y coordinate of the center is 0. And that equals r squared, the radius squared, which is 1 squared. Or I could simplify this simply to x squared plus y squared equals 1. So if I were to draw a vertical line here, that's not a problem because it crossed the graph 0 times. And technically 0 falls into at most once. But if I draw another vertical line like over here, ooh, that one's bad because this one crosses the graph more than once. If there's any vertical line at all that crosses it more than once, it fails the vertical line test. So this fails the vertical line test, which means that graph, the graph of a circle, is not a function.